All right, we're going to look at our last little section here, which deals with isosceles triangles and equilateral triangles, along with proving triangles congruent using some of the theorems that deal with those types of triangles. So get the document camera shared with you, and we are going to get going on page 61 of our notebook. So on page 61, we're going to look at isosceles and equilateral triangles. Okay, remember, isosceles triangles are triangles where two sides are equal, and in an equilateral triangle, all sides are equal. So in an isosceles triangle, I'll just draw one here. Okay, so this is an isosceles triangle. Okay, you have two sides that are the same. Okay, and that is what defines an isosceles triangle, two sides being the same. We have certain parts here. The side that is not congruent is noted as the base. And the two sides that are the same are noted as the legs. Okay, and we have what's called the base angle theorem. Okay, and the base angle theorem says if two sides congruent, so the base angle theorem, if two sides of a triangle are congruent, then the angles opposite these sides are also congruent. Okay, so here I have these two sides that are congruent, so the angles opposite of those also have to be congruent. Okay, that is the base angle theorem. And in an equilateral triangle, so equilateral, all sides are the same. Okay, since all sides are the same, then all angles, or the angles opposite congruent sides, will also be the same. Okay. So I got a couple examples here. Okay, so we want to find, in this one we want to find the values for X and Y. Okay, so here we are given that this is 4, this is a Y. These angles are all the same. And then in this one, we're given that this angle and this angle are the same. And this right here is X plus 1. Okay, so in looking through this, we're going to use these theorems up here, or the base angle theorem, that says that if you have angles that are the same, it works the other way around. If your angles are the same, the sides opposite are the same. Okay, so if all of these angles are the same, all the sides opposite. So here, these three angles are the same, so it's an equal angular triangle. So all four sides, or all three sides must be the same. So this side right here must be 4. These sides must be congruent to each other. So this is 4, so y is 4, and this must be 4. Well, down here you have these two angles are congruent, therefore these two sides must be congruent. So that is also 4. So x plus 1 must also equal 4. Subtracting 1, x must be 3. Okay, so you have found x and y. Remember, if the angles are different, all the sides are different. If the angles are the same, the side length must be the same as well. And we have a proof here to go along with it. So given B is a midpoint of segment AC, and angle BAD is congruent to angle BCD. You need to prove that angle ADB is congruent to angle CDB. Okay, and we've got a picture here to go along with it. So A, B, C, D. Okay, so we'll set up our statements and our reasons. Okay, and our first statement again is what's provided. So B is a midpoint of segment AC, and angle BAD is congruent to angle BCD. This is given. Okay, so B, let's mark this. So B is a midpoint, angle BAD is congruent to BCD. So this angle and this angle are the same. And our goal is to prove that angle ADB, so that these two angles are the same. In order to prove that those two angles are the same, we need to prove that these two triangles are the same. And it says B is a midpoint of AC. If B is the midpoint, by definition, a midpoint will split the segment into two equal halves. So this half and this half are congruent. So AB segment is congruent to CB segment. And that is definition of midpoint. Okay, definition of midpoint. And here we have these opposite angles. Now you may say, well, they both share segment BD. Yes, they do. And if we say that those segments are congruent, we could say that, but it will not get us anywhere to prove that the triangles are congruent, because I will have a side, side, and then an angle, or SSA. And we don't have that as an option to use, okay? SSA or ASS is not an option to use. So what we're going to do is, we know that these two angles are the same, and I have this big triangle ACD. So the sides opposite of those angles must also be the same. So this side is opposite and this side is opposite. So those sides must be the same. So AD has to be congruent to CD, and that was the base angle theorem that we just talked about. Okay, and here I have SAS, which if you flip back, I have SAS, side, angle, side. See, this is angle, angle, side, not angle, side, side. So there's a difference there. You got to make sure that you can use them. So now these two triangles are congruent. So triangle ADB is congruent to triangle CDB by side, angle, side. And now that the triangles are congruent, I can say that these angles over here are congruent. So angle ADB is congruent to angle CDB, and that is CPCTC. Okay, and that ends it for the unit D. So there's lots of theorems that we have in unit D that will help us get through some of the proofs. And you have those theorems here listed out on your sheet, which I'll continue to fill out in the review session. Okay, so again, I'll put some practice on here of some proofs using those theorems and just some general proof practices, so you can kind of check yourself and work through them. As always, if you have questions, please reach out and ask. And if not, we will see you in the next lesson.